Next is Pareto distribution. And again, Pareto distribution has a shape and a scale parameter. Theta is shape parameter and alpha is the scale parameter. Both are greater than 0. And the shape is like exponentials, goes like that. And it's often used in insurance industry to model potential impacts of extreme values, because that is the extreme value probabilities are a little bit higher. So usually the occurrences are in this range, but occasionally there is an extreme value, which is what we want to protect against in insurance industries. Next distribution, which is very useful distribution, is Weibull, and again it has two parameters, alpha and beta, shape and scale parameters. The shape it provides lifetime of an item with an instantaneous risk of failure, and how long will the product last. So it's a good distribution to use in case of wanting to simulate time between breakdowns. So in reliability models and lifetime of a device, these are cases, examples where Weibull is often used. The shape parameter is alpha, so alpha greater than 1, which is the usual case. Okay, so the distribution has a wear out. Okay, up and down and wears out. Okay, alpha is less than 1 is very unrealistic, because we are talking about uh, provides lifetime. Short lifetime is not likely. So alpha less than 1 is unrealistic. Alpha 1 is equivalent to exponential distribution. Then uniform distribution is the probabilities are uniformly distributed between a given minimum and a maximum. Given range, the probabilities are uniform. Triangle distribution is this. So it's like a PERT distribution. You have a minimum value, you have a maximum value, you have the most likely value. So you will have a skew if the most likely value is not at the center. If the most likely value is right at the center, you see it is symmetric. But if the most likely value is shifted towards the minimum, you'll have a right side tail. If it is shifted to the maximum side, you'll have a left side tail. But there is a hard cutoff, and that's the reason why triangular distribution is sometimes not very helpful, because it has a very hard cutoff. Instead, you would use PERT distribution. And then finally, you have cumulative distribution, which is like your own defined distribution. Okay, you don't like any of the theoretical distribution, then you want to define. And here, for continuous distribution, you have to calculate cumulative probabilities and use the cumulative probabilities to set up the distribution. Okay, let's look at this example. Okay, I'm going to copy paste these two probabilities. Right? So you have the x values and the probabilities, and then you have to set up cumulative probability. Okay. Cumulative probability is a running sum. So we can say sum of that. Okay, C8 to C8, but it always starts from C8. So when you copy, the first C8 will remain fixed at C8, the second C8 will change, so you'll get the cumulative probabilities. Okay. And the last probability, of course, it has to be 1. So it has to accumulate to 1. So now you go to define, okay, continuous distribution. Okay, so select cumulative distribution. So we have the X table and the P table. So X table is that. And the P table is the cumulative probability. Okay. Okay, and then the minimum here is 0 and the maximum is 10. Okay, so now we have a graph. So it goes from 0 to 10, 0 to 10, and the cumulative probabilities. The difference between this and the discrete distribution is in discrete, the possible values of x are exactly the ones that are listed in the probability distribution. Whereas in the cumulative distribution, which is a continuous distribution, any value between 0 and fractional values can be simulated. So see here, it gives you 4.45, which is not one of the possible values listed in X. So that's the difference between user-defined discrete distribution, user-defined continuous distribution. Well, two things. In discrete user-defined discrete distribution, you'll give X and the actual probability. In user-defined continuous distribution, you'll give the X table and the cumulative probability table, and then the minimum value of X and the maximum value of X, and any value between that min and max is a possible output coming from the distribution.